Hello, welcome to my chemistry in captivity video. Today we're going to go over some of the chemical processes in a cup of coffee and a plate of cookies. For the coffee, we're going to go from roasting all the way to brewing, and for the cookies, we are going to go from their scratch ingredients. So let's quickly go over some of the components of a green coffee bean. And the most important parts that we're looking at are the carbohydrates and the proteins. And this is going to start something called the Maillard reaction. But it's helpful to know what the other components are, where the flavors come from, where the caffeines come from, all of these beautiful little alkaloids and acids and fats that trap flavor and add aroma and add all of the things that we love in our cup of coffee. Coffee roasting is a process of hot air and airflow. What you see here is green coffee beans being roasted in a type of mini roaster. And by virtue of being a plant, these coffee beans, these coffee cherries, these fruit have both carbohydrates and simple sugars and proteins within them. And what's happening is those carbohydrates, those polysaccharides, those little molecules of sucrose are being broken down by their carbonyl groups. And those are interacting with the amino acids in the proteins. And that's creating a really distinct, beautiful profile for a process of browning, a process of flavoring, a process of aroma. Here is the Maillard reaction a little bit more visualized. So as you see, that sugar molecule has a little carbonyl group on the end that breaks off and connects to the amino acid. And you have a little aminocarbonyl reaction and water as another product of that. In higher temperatures, this reaction happens faster, and it also happens on more basic levels, as in the acidity is more basic, so it'll happen faster. This is what gives coffee its flavor, its aroma. This is what sears steaks. This is what caramelizes onions. This is what a lot of our flavors in our food come from. What you see here is a simple process of degassing. This is the ground up coffee beans releasing some of the carbon dioxide that they have. On to the chocolate chip cookies. I've written out our recipe here with all of the kitchen titles as well as the scientific titles of all of our ingredients and some of their formulas. Our big players here are definitely the baking soda, which acts as a leavener, and our flour and egg, which is our gluten and our fat and protein. Obviously, there's more fats and there's more sugar flavors and all of that, but within the process of making cookies, those are the big players. I do want to take a second and look at brown sugar here because that is a caramelized sucrose. And as I said before, caramelization is a distinct process from the Maillard reaction, but they operate in pretty similar ways. This brown butter is a perfect example of the Maillard reaction. The milk that is in the butter is reacting with itself. The sugars are breaking down and reacting with the proteins that are in the butter. And so for brown butter, we actually are getting all that flavor from the milk, whereas all the fat is absorbing all of that flavor. So if we were to take off all these foamy white milk pieces, we would be left with clarified butter, but that's not what we want. As we add the butter to our wet mixture, the sugars and the vanilla extract, I think it's a good time to go over caramelization because there was brown sugar within those sugars, and that is table sugar, sucrose, added to heat and broken down into smaller, more simple sugars like glucose and fructose, as well as those carbonyl groups breaking off and becoming flavor and aroma molecules. And we've actually been able to identify some of them for the flavors that they add. So furon is like a nutty flavor, and ethyl acetate is like a fruity flavor. Um, Again, this is just a little bit different because there's no proteins involved, but it is an interesting reaction as these things can break down and change flavor. So as I'm whipping up my sugars and my butter, I am also gonna add eggs for protein and for some emulsifier. And this is a really key aspect of the cookie because it's what holds it together. The egg is like the sticky thing that creates the polymer with the flour that I'm about to add, and that creates kind of the base or the shape of your cookie. Obviously, as I add the flour and the leavener, the dough is going to thicken up quite a bit. Now that we've seen the flour and egg come together into a type of dough polymer with all the goodies in it, now we can kind of start to talk about what happens when we heat it up. The sodium bicarbonate, the leavener, is going to decompose into sodium carbonate, water vapor, and carbon dioxide. And all of these things are going to give rise to the cookie, hence the name leavener. It's going to react, the salt is going to slow it down a little bit, but it's going to essentially bubble up and make the cookies rise as the fat in the cookies are melting within them and they are all coming together to even out under that little dough polymer that we've already made. The fats within the cookie are retaining a lot of that moisture to keep it chewy as it cools down. A lot of those sugars are browning at the edges to have a nice little crisp there. And all of these components are working together to become a very, very tasty snack. To conclude, we have gone over both the Maillard reaction and a process of caramelization, which we know are a little bit different, as well as some other basic chemistry reactions that occur within baking. This was a really fun project to undertake because it really made me appreciate some of the smaller reactions in chemistry that we get to. Oh, this is just a blooper of my cat. Okay, I hope you guys learned a lot. Bye.